NVIDIA never set out to dominate artificial intelligence. It wasn't founded to power chatbots, self-driving cars, or trillion-parameter neural networks. It just wanted to make video games look better. But a design decision made decades ago, almost by accident, turned NVIDIA into the backbone of modern AI, and one of the most powerful companies on the planet. In the early 1990s, NVIDIA was just another hardware startup fighting for survival in the PC market. Gaming was exploding, and realism mattered. Players wanted smoother motion, better lighting, more immersive worlds. Instead of hard-coding graphics instructions like traditional chips, NVIDIA took a risk. It built programmable graphics processors, chips designed to perform thousands of calculations at the same time. For gamers, this meant higher frame rates. For NVIDIA, it meant everything. Because under the surface, these chips weren't just drawing images. They were performing massively parallel computation, something CPUs were never designed to do efficiently. At the time, no one thought much of it. Then researchers started experimenting. In the early 2000s, scientists discovered that GPUs could solve certain problems dramatically faster than CPUs: physics simulations, molecular modeling, financial forecasting. NVIDIA noticed, and instead of ignoring this accidental use case, it doubled down. In 2006, NVIDIA launched CUDA, a software platform that allowed developers to program GPUs like general-purpose computers. This was a turning point. CUDA didn't just make GPUs more useful. It locked developers into NVIDIA's ecosystem. Universities adopted it. Researchers built on it. Entire code bases were written around it. And quietly, NVIDIA stopped being just a gaming company. At the same time, artificial intelligence was struggling. Early AI models existed, but training them was painfully slow. Neural networks required enormous amounts of matrix multiplication, exactly the kind of workload GPUs excelled at. When deep learning finally broke through in the early 2010s, NVIDIA's hardware was already there. Not because NVIDIA predicted AI, but because it accidentally built the perfect tool for it. By the time the rest of the industry realized what was happening, NVIDIA was years ahead. As AI exploded, demand for compute followed. Image recognition, speech models, recommendation engines. Every breakthrough required more power, and GPUs became the default choice. Companies like Google, Amazon, and Microsoft began filling data centers with NVIDIA chips. But NVIDIA didn't just sell hardware, it sold an entire AI stack. GPUs, CUDA, optimized libraries, developer tools, and frameworks. Switching away wasn't just expensive, it was impractical. Then generative AI changed everything. Training large language models required unprecedented compute, and there was only one company ready. NVIDIA's data center GPUs became the most in-demand pieces of hardware on Earth. Lead times stretched into months, prices surged. Entire cloud platforms were built around NVIDIA silicon. At this point, NVIDIA wasn't competing with other chip makers. It was defining the market. Of course, NVIDIA isn't alone. Competitors like AMD build powerful chips. Cloud giants design their own silicon. Even NVIDIA's customers try to reduce their dependence on it. But here's the problem. Hardware can be copied. Ecosystems can't. CUDA has been refined for nearly 2 decades. Millions of developers already know it. Entire AI pipelines are built around it. Replacing NVIDIA isn't just about swapping chips. It means rewriting software, retraining engineers, and accepting performance risk. That friction is NVIDIA's real moat. And every year it widens. NVIDIA also moves faster than its customers. It releases new architectures on a relentless cycle. It optimizes for tomorrow's models before they exist. And it sells not just performance, but certainty. When companies spend billions training AI models, They don't experiment. They buy what works. And right now, NVIDIA works better than anything else. This creates a powerful feedback loop. More customers bring more developers. More developers reinforce CUDA. And CUDA locks in the next generation of AI. NVIDIA doesn't need to win every battle. It just needs to remain unavoidable. And that's the real story. NVIDIA didn't predict the AI revolution. It didn't chase it. It accidentally built the system the future had no choice but to run on. There's another reason NVIDIA's position is so hard to challenge. AI doesn't scale linearly. Every new model is bigger than the last. More parameters, more data, more compute. And as models grow, efficiency matters more than raw power. This is where NVIDIA quietly dominates. Its chips aren't just fast. They're optimized end-to-end. The hardware, the software, the drivers, the compilers, all designed together. That integration squeezes more performance out of every watt, every rack, every data center. For companies spending millions or billions AI training, those efficiency gains compound fast. NVIDIA also benefits from something few companies ever achieve: default status. When a startup raises funding to build an AI product, it doesn't debate chip strategy. It buys NVIDIA. When an enterprise launches an internal AI initiative, it doesn't experiment. It buys NVIDIA. When governments build national AI infrastructure, they don't take risks. They buy NVIDIA. That default choice creates momentum that's almost impossible to reverse. And here's the paradox. The more companies try to move away from NVIDIA, the more they reveal how hard it is to replace. Custom chips struggle with flexibility. Alternatives lag in software support, and performance gaps widen at scale. Meanwhile, NVIDIA keeps shipping faster chips, better tools, more optimized AI frameworks. Not because it has to, but because staying ahead is the only way to remain unavoidable. That's why NVIDIA isn't just an AI company, it's infrastructure. The same way Intel once powered the PC era and cloud providers power the internet, NVIDIA now powers intelligence itself. And whether the future belongs to chatbots, robots, or systems we haven't imagined yet, it's increasingly clear what they'll all be running on. This is Biz Decoded. Like and subscribe for more videos like this.